In previous sections, you looked at debugging, and you looked at how you can use the debugging tools to see what's going on in your application while you're developing. But what happens when the application's deployed? You're not going to be there to observe what happens. So what you want to be able to do is monitor your application and record what's happening while it's running. Now that's very useful when you can't be there to observe the application, and particularly when you can't be there to enter debug mode and look around. Well, the .NET Framework provides tracing components, and tracing is basically the process of monitoring an application and recording what's happening. And the tracing components that the .NET Framework provides are trace sources, trace switches, trace listeners, and trace filters. Let's explore each of those. A trace source is the mechanism used to send messages with information to one or more targets. So you'll decide where you want to record information. Could be to a text file, could be to an XML file, could be to the event viewer, could be to the output window. And it's the trace source's job to take messages and send them to the designated target. The System Diagnostics namespace provides the trace source class to perform this functionality. And there are three methods that you'll use. The trace information method writes an informational message. The trace event method records that an event has occurred. And the trace data method records not only that an event occurred, but also records data about that event. So if you just want to record that somebody started the application or data was retrieved from a table, you can use trace information. If you want to record that invalid data was entered or that an exception was handled, you could use the trace event method. And if you also wanted to record information about what was happening when that event occurred, you could use trace data. So the trace source's job is to send messages. The job of the trace switch is to enable or disable tracing and decide on how much information gets included in messages. So the trace source can't send a message without checking with a trace switch to see if the message should be sent and how much information should be sent. So you can view the trace switch as an intermediary between the application and the trace source, which is sending the data. And to create a trace switch in your code, you'll use the source switch class. And you'll use the level property to specify what level of events you want the trace source to pass on to the listener, whether the listener is an XML file or the event viewer or what have you. The trace listener is what actually receives the messages and either displays them in the output window or records them for posterity. So the trace source passes the message to the trace listener, and it's the trace listener's job to actually record it. And for every target you want to write to, you'll have a listener. The default trace listener writes to the output window. You can use the event log trace listener if you want to write to the event log. You can write to text files with the text writer trace listener. You can write to XML files with the XML writer trace listener. You can write to a text file in delimited format using the delimited list trace listener. And finally, you can write to the console with the console trace listener. And the last of the four pieces is trace filtering. You can control the information that's recorded by changing the level property of a trace switch. So if you set it to all, then all events go through. You can turn off event recording. You can decide you only want critical events, or critical and error events, or critical, error, and warning events, critical, error, warning, and information events, and finally critical, error, warning, information, and verbose events. So you might decide the only thing you're going to write to the event log are critical errors, the only thing you're going to write to an XML file is critical, error, and warning, and maybe you want to display in the output window absolutely everything. You can decide for each listener what level of information you want to pass. And we'll see in the demo that you can set all of this up in code, and you can also use configuration files. And the benefit of using the configuration file is, first of all, you don't have to set everything up in code, and secondly, you can make changes without having to rebuild your executable. So let's go explore how we enable tracing in an application and what kinds of information we can record. I'm in the debugging applications project, and this application has already been set up to trace information. So let's explore how we did that. The first thing I did was create this file called AppSource. Let's look and see what's inside that. And it contains two static classes, and the reason these classes are static is because I want to be able to use them without having to instantiate them. And I want to be able to use them throughout the project. Well, the first thing I do here is create a new instance of the TraceSource class, and I call this AppSource. And remember, the TraceSource class is the mechanism that's used to send messages to one or more targets. And I'm going to give this TraceSource a name, Debugging AppSource. Then I'm going to create two additional classes, and these are TraceSwitches. And the TraceSwitch's job is to either turn on or turn off tracing, and also decide how much information gets included in messages. So the TraceSource can't send a message before it talks to the TraceSwitch. So I have two TraceSwitches in here. They're both static members of static classes. So the first static class is ProjAppDefaultSwitch, which will be my default switch, and then I have ProjAppCriticalSwitch, and as the name implies, we're going to be using this one to record critical messages. And then each of these has a member, AppDefaultSwitch, AppCriticalSwitch, and those are instances of SourceSwitch. So static classes with static members means that I can call all of these in code without having to instantiate. And the two switches, I'm using conditional compilation because later on I'm going to define these in a configuration file and not in code. So I have this conditional compilation trace defined in code, and if I go to the project properties and I go to the build page, I can see that I have defined this symbol. So this code will get compiled into the project. Later on we'll get rid of that symbol and we won't be building this code into the project. We'll be using a config file for that. Okay, so now I've set up tracing. Now let's see where I use it. Let's look in the products form. The products form retrieves information from the products table and then also retrieves information from suppliers and categories to display in these combo boxes. And in the load, the first thing we do is retrieve categories information and populate the categories table, and then we want to record that information. So after retrieving the category information, I run this code. Remember, AppSource is a static member in the ProjAppSource static class, so I can say ProjAppSource.AppSource, and that references my trace source here. And the trace source has a trace information method. And the trace information method writes an informational method to a trace listener. And the default trace listener is the output window. So what this will do is write to the output window that the categories table was loaded with a certain number of records, and that will be the count of the records in the categories table. Then we'll do the same thing for the suppliers table. We'll retrieve the information, populate the suppliers table, and then write that information to the output window, and then do the same thing for products. So let's run this form and see that. When I load the products form, I retrieve the information for the three tables, and now if I look in the output window, I see from the debugging app source an informational message, and I see that the categories table was loaded with 8 records, suppliers with 29, and products with 77. So what I've managed to do, very quietly and without any significant impact on performance, is record what just happened. So I could use trace information to record when the application was started, when users opened and closed forms, how long it took between the time they add a record and save a record. I could be monitoring those types of things and come up with statistics on usage. What I can also do is record errors. So there's a validate data method in this form, and what it's going to do is validate the last control the user was on to make sure that's valid data, and then if that works, call the endEdit method of the product's binding source to commit pending changes. If any of that data is invalid, that will throw an exception. Well, I certainly don't want the application to blow up in front of the user, so I'm going to catch that. And I'm then going to show a message to the user, invalid data was entered, do you want to cancel your edits? If the user says yes, then I'll call the cancel edit method of the binding source to cancel those pending changes. If the user says no, I don't want to cancel edits, then they'll still be in the form and they can correct the data. But if they enter invalid data and cancel that, I want to know why. I want to know what types of invalid data users are trying to enter, and maybe that will help me build a better form. So here I'm going to use the trace event method of the trace source class. And the trace event method takes 3 arguments. The first is the event type. And I'm going to call this an event type error. It's not a critical error because it's not crashing the application. It's just a data error. So I'll call this of type error. The second argument is a number. It's the event ID. And this is arbitrary. So I chose 5 here. And then the third is the actual message we're going to write. Invalid data entered into products table, and then more detail, which I'm going to get from the exceptions message property. Okay, let's run this and let's catch an event. So I'll go into the products form and I'll add a new product. I'll select a supplier, I'll select a category, I'll click save. Alright, that's invalid data, so I will cancel the edits. And now I'm going to go into the output window, and I've trapped this error. So from the debugging app source, remember the event is an error. It's error number 5. Invalid data entered into products table. Column product name does not allow nulls. So now, maybe if I see this happening a number of times, I'll put some code into the save button to check to see if the product name is empty, and then tell the user and send the cursor to the product name. So we can intercept this and avoid invalid data occurring. Well, so far this is all well and good. We're capturing good information, we're trapping events, and we're displaying it in the output window. But one of the benefits of tracing is that you can record this information when you're not around. And in production mode, you're not going to be looking at the output window. So what we want to do next is record this information someplace where we can go see it as the developer. So let's look at this switchboard form. It's the main form that shows up when I start the application, and there are 3 choices here. Enable the event log listener, the text writer listener, and the XML writer listener. So let's look at the code for those. We come down here. If I've checked the event log listeners checkbox, then I'm going to create a new instance of the event log trace listener class and call it debugging apps event log listener, and then I'm going to add this to the collection of listeners belonging to my main trace source. Now this app source, or my main trace source, already has a listener, and that's the output window. That's the default listener. But I'm going to add the event log listener to that. And if I check text writer, then I'm going to create a new instance of the text writer trace listener class. And I'm not only going to give it a name, but I'm going to tell it what text file to write. /appdev debuggingapps.log. And then I'm going to add that to the collection of listeners in the trace source, and I'm going to specify that I want the date and time recorded. And then finally, I'm going to do something similar with XML. I'll create a new instance of the XML writer trace listener and specify that it should be writing to the debuggingapps.xml file, and also that I want the date and time recorded. And so now, let's run this application. I'm going to check event log, text writer, and XML writer, launch the products form, record the information that the 3 tables were filled, and make the same mistake when adding a product, save, cancel, exit. Now I exit the application, and let's go see what happened. If we go into the appdev folder, here are the 2 files, debuggingapps.log, debuggingapps.xml. Let's open the log file, and here's the same information that we had seen in the output window earlier. Let's get word wrap on. There we go. And now we're recording, for posterity's sake, that information. The categories, suppliers, and product tables loaded, and invalid data was entered, and when. There's the date and time. The same information is being written to the XML file. And of course there's a schema attached there. But somewhere in there we go. There's the information about invalid data. Here's the products table being loaded. Here's the suppliers table being loaded. And then the last place we want to look is in the event log. So we'll go into Control Panel, Administrative Tools, open up the Event Viewer, and look in the application logs. And here's the information message that the categories table was loaded. Source is debugging apps event log listener. Suppliers table, products table, and here's error number 5, invalid data entered into products table. So now you can see that this information is being logged on a more permanent basis, and we can come back and look at it on a periodic basis and see what's going on. The next thing we want to look at is filtering out some of this information. The trace switches have the ability to decide how much information gets recorded in messages. So at the top of this file, in the load, I'm creating additional switches. So at the top of this file, in the load, this is when the application loads, I'm configuring the switches. I'm setting the main switch to app default switch, and I'm setting its level to source levels all. So it's going to record all information and let all events through. And then I'm going to set the level for the critical switch to critical, meaning only critical events get through. And then in the main form, I have the ability to filter events. So if I were to click critical only, then I'm going to change the default level for this switch from all to critical, or I can set it to error or to warning. And then in addition, I can filter at the individual listener level. So if I click the filter button, then I'm setting the filter for the event log listener to error. Otherwise, it's verbose. So what happens now? Let's run this again. Let's enable the event log listener, and let's filter messages. And we're filtering because we only want errors to get through. Okay, let's run this form. Let's add. We'll make this error and exit. And now let's go back into the event viewer and look at the application logs. And notice that we don't get a second round of the informational messages. The only thing that gets recorded is the error message. So certainly writing to the event viewer, we might want to decide whether or not we want this type of informational message as opposed to the errors. And we can do that through filtering. And so now let's look at one last thing. So this now is for all listeners. We want only critical, error, and warning messages sent, not informational messages. So now we'll enable the event log, text writer, and XML writer listeners. Run this one last time. Record the error and exit. And now, come and look at the log file, open this, and see that, once again, we did not record the informational messages, we just recorded the errors. So you can do filtering at the individual listener level or at the trace source level. And so you have a fair amount of power to decide what type of information you want to record and where you want to record it. And now the last thing we're going to look at here is using config files instead of defining things in code. It's a fair amount of code we had to write here, and of course we probably need to write it to learn how to do this, But if we want to make changes, we don't want to have to recompile the application. So what I'm going to do is for all of the code that is conditionally compiled, trace defined in code, I'm going to now get rid of that compilation symbol. And now, when I compile this application, this code, which is now grayed out, is not going to be built into the application. Rather, I'm going to rely on code in the app.config file. So here's the equivalent. Here's the XML that sets up the text writer trace listener, the XML writer trace listener, the event log trace listener. Here are the switches and their levels. So what I've now essentially done is only left in the main trace source, but taken out all the rest of the code. And now when I run this, let's enable all of these, click the products form, add, save the invalid data, and now come back into here, open this up, and we're back to recording. And if I want to make a change now, all I need to do is go into the app.config and change this code. I don't have to recompile the application. So tracing is a very powerful feature. It takes a little bit of getting used to. The code's a bit verbose, but once you get a handle on it, it's a very powerful feature for recording information in your application at runtime and in production so that you can see what's going on without having to be there. Visual Studio 2005 included unit testing, but it only shipped in the higher-end SKUs, the Team Edition or Team Suite SKUs. In Visual Studio 2008, unit testing ships in Visual Studio Pro and above. What is unit testing? Well, unit testing is basically methods that call, and therefore test, class methods. So let's say you have a class in an application and you want to test the methods. Or you have a class library, which consists of classes, and you want to test those methods. You could write a test harness, which is an application, and then call those methods. You could run the entire application that's going to use those. But a unit test is a method that calls one other method. Therefore, you can test more discrete units of code without having to run the entire application. And in a unit test, you're going to call the methods and then check to see if they return the expected value. Well, you've always been able to write these types of tests by hand, but now you can have Visual Studio generate them for you. And when Visual Studio creates a unit test for you, you're going to use assert statements in the unit test code, and that's how you're going to verify that a method performs as you expected. And by performs as expected, we mean return the expected result. And unit tests are going to start in a passing or an inconclusive state until you use an assert to specify otherwise. So we'll see that by default, when you create a unit test, Visual Studio adds an assert statement to specify that the results are unknown. And then you're going to use assert statements to compare the expected result with the actual result and report on whether or not the method works. So as an example, you can use assert.requal and pass into that both the expected result and the actual result. If they're equal, then the test succeeded. So let's say you have a method that returns the total amount ordered for a particular product. And you're going to test it by passing in the product ID 7. Now you know the actual amount that was ordered, and therefore that's what you expect the method to return. So you would call assert.requal, pass in the expected result, which you know, and the actual result, which is what the method will return. And again, if those are equal, then the test succeeded. If they're not, the test failed. Another assert you can use is true, and you'll use that to verify that a condition is true. If it is, then the test succeeds. If it isn't, the test fails. You can also use assert.fail to cause the test to fail. So you might have a method that is crashing. So in your unit test, you could wrap it in a try-catch, and in the catch, add the assert.fail, because obviously if the method crashes, then the entire test fails. So let's go see how to create unit tests in Visual Studio. I have the Northwind Data Miner project open in Visual Studio, and this is a class library project, and it has a class called Data Miner. Let's open that up, and it has two methods. One, get order amount by product, which is going to take as an argument a product ID, and then it's going to create a SQL query to return the total amount ordered for that product. We're then going to connect to the Northwind database on SQL Server, run that query, and return the results. The second method in here is get order count by product. It takes a product ID, and the query this time returns the number of times this product's been ordered. Again, connect to the database and return that. So there are two methods in here, and this class library is going to be used to provide some reporting to front-end applications. So I've written this and now I want to test it, but I don't really want to have to either create a new Windows application to test this or go run the application that calls this. Maybe that's a fairly large application. I just have two methods here. I would just like to test these. So now I want to create a unit test to test this method and the other one. So all I need to do is right-click inside a method and select Create Unit Tests. And that brings up the Create Unit Tests dialog. And it shows me all of the methods in this class. The one I right-clicked in is checked. I can check the other one. So now I'll create unit tests for both of these. Visual Studio will create a new test project for this and add it to the solution. I can click the Settings button and set some options here. The default file name and class name and method name are in here. By default, I'll create a file, Data Miner Test, and then a class Data Miner Test, and then for each method, that method with test at the end. I can change that if I want. Also notice that in the General section, by default, all tests are going to be inconclusive by default. And also notice in the General section that Mark All Test Results Inconclusive by default is checked. That's the default. We'll leave that on for a minute and then see what happens. Okay, I'll click OK. And now I'll click OK to generate my unit tests. I'm going to enter a name for the new testing project. So I'll call this Data Miner Tests. Hit Enter and create the project. So now let's see what happened. So now Visual Studio has added to this solution a project called Data Miner Tests. And this class Data Miner Test contains my actual unit tests. There's also a text file in here with a little more information on how to author and run unit tests. Okay, so let's see what's in the Data Miner Tests class. We have a using statement for Northwind Data Miner, which is the assembly that we want to test. And so in this Data Miner Tests class, Visual Studio has added a reference to the class library. That's good. We're also using classes in the namespace Microsoft.visualstudio.testtools.unittesting. And so we have the Data Miner Test class, which has a test class attribute, and that identifies that the class contains unit test methods. And then if we scroll down, here's the unit test for the get order amount by product method, and that method is named get order amount by product test. It's attributed test method to identify that it is a unit test. And so this code creates a new instance of the Data Miner class, initializes the argument that gets passed to get order amount by product, that's product ID, sets it to 0. Now we know that get order amount by product returns a decimal, so the test creates a variable called expected, which is a decimal, and then also a variable called actual. And then we run the test. So this line of code here actually runs the test, passing in a product ID and returning the actual amount. Then the question is the value we got back equal to the value we expect? So then the unit test uses an assert. The test is going to assert that the expected value is equal to the actual value. If it is, great, the test worked. If it's not, then the test is going to fail. And then after that is the assert.inconclusive. Now remember, when we created the test, we saw an option that specified that by default, the tests would have inconclusive results reported. So I'm going to comment this out, and probably in the future not include that in tests. Let's look at the next method, getOrderCountByProductTest. Does the same thing. GetOrderCountByProduct takes a product ID, so the test defines the variable product ID as an integer. This method is going to return an integer, so the expected variable is an integer, and therefore so is actual. Then we call this method and assert that the expected result will be equal to the actual result. Then I'm going to comment out this assert.inconclusive. So these are my tests. The next step is to specify a product ID and also specify the expected amount. So let's test product number 17. So I'll change this to 17. And I know, because I've run this, that product 17 has $35,482.20 worth of orders. So I'll set the product ID equal to 17 and the expected equal to this decimal amount. And now I'm ready to test getOrderAmountByProduct. And I also know that product 17 has been ordered exactly 37 times. So I enter the arguments, I enter the expected value, and now I'm ready to test this. So I'll select Test, Run, All Tests in Solution, and run these tests. Project gets built, the tests are run, and I can see that they both passed. Both of these methods returned the result that I expected. Okay, so now let's make a change. Let's say that we're really expecting 42 to come back. Now I'm going to rerun these tests. I could go to Test, Run, All Tests in Solution, but what I can also do is in the Test Results dialog box, just select Run. And that will run both of these tests. So let's rerun these tests. And I can now see that getOrderAmountByProduct succeeded, but getOrderCountByProduct failed, and the error message is the assert.rEqual failed because we expected a 42, but we actually got back a 37. So this tells us why the test failed. So now we'll set this back to 37. We can run it again. And when we do that, we're going to rerun the test that failed earlier, which was getOrderCountByProduct, and now it's passing. So we can use the test results window. We can also use the test view window. So I select Test, Windows, Test View. And that shows me this window here. Let's resize it so we can see a little better. Here are the tests, so I can run these from here. Click Run Selection. That runs the test I've selected. If I want them all, I can select both of them and run. So the unit test gives me the ability to quickly test one or more methods with a minimal amount of code. I don't have to create an executable test harness and wait for that to start up. I don't have to use the real application that's going to use these. The unit test is a handful of lines of code. It's very fast, runs the method, and then I compare the result that came back with the expected result. That gives me the ability to code, test, go back and recode, test, and do an iterative process very quickly and very easily. Unit testing is a fairly large topic, and this was a pretty high-level overview, but this gives you a good introduction to how you can generate unit tests in Visual Studio.